Hello, grade 11s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abudiwa Sos Ugobela Wemets. And without any further ado, let's look at these questions that we have here. Okay, so we are given two blocks of masses 5 kg and 2 kg are connected by a light inextensible string. A force F is applied on a 5 kg at an angle of 20 degrees to the horizontal, and the system of blocks accelerates to the right at 2 meters per second square, as shown on the diagram below. The kinetic frictional force on the 5 kg block is 10 newtons. Then we are also given that the acceleration is 2 meters per second square. Now 3.1 says define the term normal force. So we know that the normal force is the force exerted by the surface on an object it is in contact with, and it always acts perpendicular to the surface in which an object is placed, right? So that's how you are expected to define normal force according to your CAPS document. Then 3.2 says draw a free body diagram of all forces. So note this one, of all forces acting on the 5 kg block. So that means whether vertical or horizontal. So as we can see here, it's 5 marks. And then what we need to do here, this is 3.2, have our dot indicating the object at the 5 kg. And then down here, we know that we always have the gravitational force. And then up there, because it's on a surface, it is experiencing the normal force. And then we have our force applied going into that direction at an angle of 20 degrees. And then this is tension here, as we can see the rope. But then on the same direction with tension is your kinetic frictional force. Since the object is going to the right, or the system is accelerating to the right, that means the kinetic frictional force obviously will have to oppose the motion and act to the left, right? So just like that, how many forces have we got? It's definitely 5. So 5 for 5 marks, and then that's how they're gonna mark. It's 1, 2, 3, 4, 5, right? And then now 3.3, they say now calculate the tension in the string for 3 marks, right? So since this is 3 mark, we can tell that it should be a fairly simple process to do that. So, okay, now trying to calculate the tension from this, we can see that as of right now, we don't have the magnitude of the force applied. Therefore, we cannot be calculating with this 5 kg block. But then if we can just try to draw the free body diagram for the 2 kg block here, remember the advice that I gave you, always ensure that you also draw the free body diagram for the other one. Yes, this one is the one that will give you marks, but then this is a system of blocks. So that means eventually somewhere you will need the free body diagram for the other object there. So now this is tension. Remember, it is being pulled upward. So if this system of block is accelerating to the right, that means this block here is being pulled upward. Therefore, its tension needs to be longer than the gravitational force. Now we are saying the pulling force of the tension is greater than the gravitational force. So, okay, now when we have it like this, we can calculate our tension using the 2 kg, since we only have 2 forces here, and then it's much easier to calculate using that one. So let's just say for 3.3.1, this is F net is equals to MA, right? And then note, this becomes our positive direction. It is the direction of motion, right? So it is going upward. Therefore, this we indicate it as positive, but then down here now it would be the negative direction. So the equation needs to be tension minus Fg, and then this is equals to MA. So note this, if a system or a block is pulled upward, if block is pulled upward, then always have this at your disposal. This is T minus Fg. But then if block is moving downward or is being pulled downward, then it becomes Fg minus T. So always note that. So now because the block is being pulled upward, it becomes tension minus Fg, right? Then, okay, now this is our tension. And then breaking down the Fg, we know that's mass times the gravitational acceleration and then ma. Now this is tension. Our mass is 2. And then here we have 9.8. And then our mass is 2. But then we are given the acceleration. Remember, do not assume that the acceleration is 0. It is given there. So it could only be 0 if they had told you that this is moving at a constant velocity or it is stationary or at rest. But then they did not mention that. They told you the system of block accelerates to the right at 2 meters per second square. So you are supposed to substitute it there. Then this is 4 plus. If we transpose it over to the side, that's 19.3, and then adding the 2 there will give you 23.6 newtons. So that's how you were just supposed to calculate the tension in the string for 3 marks there. So to calculate for 3.3.2, you're still going to make use of this free body diagram that I've drawn here. So we want to calculate force F. But then we can see that our force here is given diagonally, and then it becomes a problem to calculate using diagonal forces. So every time we are experiencing such a situation, we then have to remember that we can resolve all the forces that are acted at an angle to the components. So we'll end up having the Fx here, and then since it's being pulled, then we know that the Fy has to be up there, right? So this is Fy. Now we can then calculate this by simply saying this our horizontal forces. So our horizontal forces are tension, Fk and Fx. But then since this is being pulled to the right, this here becomes the positive direction, and this over here becomes the negative direction. Now it's easy to spot this. The negative direction will always be where Fk is. So wherever you see the kinetic frictional force or any type of frictional force, then just know that's your negative direction, because frictional force is always opposing the motion of an object. Then this will become F net is equals to ma. Then this is Fx minus the Fk, and then minus tension is equals to ma. So I'm subtracting both of this because they're on the negative direction. Then remember, Fx breaks down to F cos theta, which our theta here becomes 20 degrees. But then we do have our kinetic frictional force. It is given here. They said the kinetic frictional force on the 5 kg block is 10 Newton. So you see the importance of having to collect your data and reading your statement very carefully. Then that's 10. But then our tension, remember, we just calculated the tension in the previous question. Though we had calculated the tension using the 2 kg block, note that this is the same string. So the tension in the 2 kg block is the same tension in the 5 kg block. So every time we are working with a system of blocks, just know that the tension for these two objects is equal. So tension for 2 kg is equal to tension for 5 kg. But also as well, acceleration for the 2 kg is equal to the acceleration for the 5 kg. Right. Then here we have our tension. It's the one that we calculated is 23.6. And then the mass, remember we are using the 5 kg block here. The mass for the 5 kg block is obviously 5. We do have the acceleration. It's 2, right? So that's 2. Then now this is going to be F cos 20 degrees, and then punching this into your calculator, you have negative 33.6, and then that's 10 over there. That's F cos 20 degrees is equal to, if we take this one and transpose it to the right-hand side, we end up with 43.6. Let's divide both sides by cos 20. So I'm keeping this cos 20 because I don't want to find myself having to chop off values because of rounding off. Then this is 46.40 newtons, right? So punching that into your calculator, you have 46.40 newtons. and that becomes the force F that is shown on the diagram there. Now, for 3.3.3, they ask us to calculate the coefficient of kinetic frictional force on the 5 kg block, right? So again, let me just erase the part here. Okay, so to calculate the coefficient of kinetic frictional force on the 5 kg block, we know that the formula is Fk is equals to mu k times n, right? Then what we are actually looking for here, what we are actually looking for is the mu k. So we are looking for this here. So we are given the kinetic frictional force is 10 newtons. But then again, we know that for this type of question, we need to first calculate the normal force. Now we can see that this is being pulled at an angle. This is being pulled at an angle. And then we know the formula to calculate when this is being pulled at an angle is normal force is equals to Fg minus Fy. Right. Let's say maybe you happen to forget it. You can still deduce it from your free body diagram here. If you can just consider the fact that your upward forces are always equal to your downward forces, then you might end up having Fn plus Fy is equals to Fg. Now, because you are trying to calculate the normal force, you obviously have to make the normal force the subject of the formula. Then you end up with Fg minus Fy. So that's how we deduce that formula there, right? So we have derived that formula from that expression there. Okay, so now to calculate the normal force, we will say this will become, so let's first calculate the normal force. This will be mg minus F sine theta. And then our mass is, so our mass, remember, is for the 5 kg. So 5 times 9.8. And then the force, we just calculated it in the previous question, 46.40, and then sine 20 degrees. Now, all you have to do is punch all this into your calculator. So it's supposed to be 33.13 Newton, excuse me for that. And then now that you got the value there, you need to then take it to this equation here. Take it to this formula. You have your Fk, so that's Fk is equals to mu k multiplied by n. My Fk is 10. My mu k, that's what I'm looking for. But then here I have 33.13. So obviously I have to divide both sides by this 33.13. So 33.13. And then now my coefficient for kinetic friction is equals to 0.30. Right. And that's how I have it like that. So that's how you were supposed to tackle this question for a total of 18 marks. So please press the thumbs up button if you've enjoyed the lesson and then you have also found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.